So today our topic is algebra of complex numbers. Algebra of complex number. In this algebra, we will study about the addition, subtraction, multiplication, and division. So as this is the first is addition of two complex numbers. Addition of two complex numbers are like this. Suppose that we have taken z1 is equal to a plus ib and z2 is equal to c plus id. Okay, these are two complex numbers. So how can we add these two complex numbers? Subtract, multiply, and divide. So look, a plus ib, whenever we will add z1 and z2, then first of all we will write it as a plus ib, then plus c plus id. Okay, the process of addition is in such a way that first of all you will add the real parts, add the real parts a and c together, you will get the real part and the sum of imaginary parts, so ib plus id. By this we will get a plus c and plus I can be common and it will be b plus d. So this is the sum of two complex number z1 and z2. Okay, where we need to add real parts together and the imaginary parts together. The second is subtraction of subtraction. In subtraction, z1 minus z2, that means it will be a plus ib minus c plus id. Okay, in order to subtract, we will do the same. A minus c plus I will be common and this will be b minus d. So this is the subtraction of two complex numbers. Okay, the third is multiplication. Multiplication. In order to multiply these two, z1 and z2, z1 into z2, it will be like a plus ib into c plus id. We can multiply like this. We can multiply a with c plus id plus ib into c plus id. Okay, now just multiply it, we will get ac plus iad plus ib plus I square bd. Okay, now after this we can say that this is equal to ac plus both from these two mid two terms, I is common and it will be AD plus BC plus I square will be minus 1 into BD. So hence we can say that Z1 Z2 is equal to AC minus BD. Look, the last term minus 1 into BD will be minus BD. This will be the real part of the product and imaginary part will be I AD plus BC. So this is the product. Note it down. Inverse of a complex number. The complex number is given as z is equal to a plus ib. Then its inverse will be taken as 1 by z. 1 by z can be written as z inverse, and this will be 1 by a plus ib. Now we will use the process of rationalization here. It will be a plus ib, rationalizing it, so it will be a minus ib and a minus ib. The process of rationalization says that change the sign in between the terms and then multiply in numerator and denominator. So we did this. Now it will be a minus ib in the numerator, and in the denominator, look, it is in the form of a plus b and a minus b. So the formula having a plus b, a minus b is a square minus b square. We will use it and we can write a square minus ib whole square. After this, it will be a minus ib by a square minus I square b square, and hence finally we can say a minus ib divided by a square. I square is minus 1 and minus minus plus 1, so it will be a square plus b square. In order to write it separately as the imaginary part and the real part, we can write it as a by a square plus b square minus I by b by a square plus b square. So this is the value of z inverse. It means that you can say that this z inverse can be represented as a minus ib by a square plus b square, and that's equal to a by a square plus b square minus I b by a square plus b square. So this is the format of the inverse. Note down. Written? Yes, sir. Okay. Now, in order to know about the next algebraic property of the complex number, that is known as division of complex number, division of two complex number. The complex number was z1. Z1 was a plus ib we have taken, and z2 was c plus id. Okay, it means that we have to find out z1 by z2. It means that it is a plus ib by c plus id. Now, if you will look at c plus id carefully, it is like this: a plus ib into 1 by c plus id, right? Like in the previously we have discussed that if z is equal to a plus ib, the z inverse will be c plus I, sorry, uh, 1 by a plus ib. Okay, same as c plus id can be taken as z2 inverse. 1 by c plus id can be taken as z2 inverse because it is 1 by c plus id. It means that we need to find out the inverse of c plus id, and the inverse of c plus id will be same as the inverse of a plus ib, and it will be a plus ib it will be into c by c square plus d square minus I d by c square plus d square. Okay, or we can say it as a plus ib into c minus id divided by c square plus d square. So this can be the value of z1 by z. We have just replaced it by the previous example, by the previous concept. Note down. Z is equal to a plus I be a complex number, then modulus of Z can be written as mod Z, can be represented as like this, will be mod of a plus ib, and it is defined as root over a square plus b square. Okay, a square plus b square, where we can say that the real part of z is a and the imaginary part of this z is b. As we can see that a is the real part of z and b is the imaginary part of z. Okay, you will always see that you should note down here that the modulus of z will be always greater than equal to 0. Okay, it will not be less than 0. Okay, it will be always greater than and equal to 0. In order to write modulus of z in some another way, we can say that mod z is known as the absolute value of z. Absolute value of z. Okay, for example, we can solve a question here like find mod z if z is equal to 5 plus 5i. Okay, 5 plus 5i. So simply the real part and the imaginary part, we will take it and make it a square root. So z is equal to root over 5 square plus 5 square. It will be 5 5 are 25, 5 5 are 25. It's under root. It's root 50, and root 50 can be taken as 50 factorize it to 25 5 5. So it will be 5 root 2 units. Answer. One more example we will solve. I'm writing here, you can see. Find mod z when z is equal to minus 7i. Okay, so in this case you need to choose that what is the value of a and b. So the real part of z is 3, and what is the imaginary part? Tell me, what is the imaginary part here?
7.
Minus 7, correct. Minus 7. So mod z will be 3 square plus minus 7 square root over, it will be 949 root over, that is 58. So root over 58 units. In both of the things, in both of the examples, you need to understand one more thing. Let's discuss. Just note down. What I told here, what I told, that mod of z must be greater than equal to 0. Okay, as we know that whenever there is a condition of square root, okay, like suppose that there is a value root 4, randomly I have given root 4. What is the value of root 4? Say 2. 2. You will say 2, but it is a wrong answer. It's not wrong, it's incomplete answer. 2 is not only the answer. There is two values plus minus 2. That means 2 and minus 2 both are the answers of root 4. Why? Because root 4 can be, if sorry, because 2 square is also 4 and minus 2 square is also 4, right? That means there is a condition of, there are two conditions for to obtain 4. There are two options to obtain 4. One is 2 and another is minus 2. That's the square of 2 is 4 and square of minus 2 is also 4. Here in the both of the answers we have, here you can see in this question that root 50 is there. That means after root 50 the value will be not only 5 root 2 but it will be plus minus 5 root 2, plus minus 5 root 2. And here also it is not only root 58, it will be plus minus root 58. But the question is, why do we write only root 58 and only 5 root 2? This is the question here. Because we are finding mod z. We are finding mod z. And the condition of mod z is z mod z always greater than equal to 0. The condition for the value which is greater than 0, that is always positive, and any value which is negative, that will always be less than 0. So what is the thing that we are doing here? Automatically we are taking root under 58. Why? Because this is a positive value, and automatically we are taking here 5 root 2 because 5 root 2 is positive. So this is a cross question, can be asked by anyone, any of your friend, any of your guardian, that why are you taking 5 root 2 only? Why not minus 5 root? So you should answer that mod z is the value which is always greater than and equal to 0, and minus 5 root 2 is not greater than equal to 0. Therefore, we will always take mod z, that means the positive value of any answer. So that is 5 root. Any doubt?
No, sir. No, sir.
Okay, the next is properties of modulus of complex numbers. The first property is, first of all, let's say that let z1, z2 are the complex numbers. Then the first is, if you will say that minus z1, then it will be equal to z1 only. Minus z1 will be the mod of z1. Okay. The second condition is mod of z. Let's see, take one more. Z1 and z2 are the complex numbers. Okay. Then we can say here, don't take z1, take it at minus mod z is equal to mod z. Okay. Mod z will be 0 when, if and only if z is equal to 0. That means if any complex number is 0, like if z is equal to 0 plus 0 I into 0, then only mod z will be 0, otherwise it is not. Number 3 is uh, mod of product of two complex numbers can be taken as separately z1 and z2, and the fourth one is the product, and it is the product, sorry, quotient of two complex number will be mod of z1 by mod of z2, provided mod of z2 or z2 should not be 0. Okay, because if it will be 0, then its complex number will be undefined, because anything divided by 0 is undefined. Okay, just note down everything.